100%, can do it 90%, can do it 80%, you understand? It's either you can do it or you cannot do it. Do you understand? So that's the what? That's the gradation. Now, let's move on to courses. I want to rub this off. Please, if something is confusing you, bring it back. Let's discuss it. Now, let me make a note. Some textbooks might want to do something like this. Morphological / continuous. And some will give what? Physiological / is continuous. To some extent they are right, but to some extent they are also wrong. If they include fingerprint under morphological, fingerprint is not continuous. Do you get it? So if you want a detailed explanation, it is better for you to discuss both of them. If you notice, if you look at the two gradations I gave you, they are also similar. The difference is just that fingerprint is not more on this side, it's on that other side. Understand? So that is why fingerprint is the reason why I cannot slash both of them as what? As meaning the same thing. One is talking about how you appear, how I can determine it. One is talking about if I can grade it or not. So please don't ever mix the same or mix these two of them as the same. Don't ever call morphological variation continuous. They are different. They are talking about different characteristics. Please, do you get that? Your.
That's my question. Things that maybe continuous and physiological.
Yeah, it looks like.
Can we have conditions that is continuous and not physiological? Like.
Okay. Like something that looks like fingerprint, Abi. The way fingerprint went to the other side, another one coming to this place, and it's not physiological. You can't actually see it. This is the reason why. If I tell you to do something, you will do it for me. If I tell you if you can do it, you will do it. If I tell her to do it, she might not be able to do it. Something I have to tell you to do before you can show me how to do it. There's no way I can grade it. An example is this: if I give you a test, you get today, you get 90, she gets 80, he gets 70. Tomorrow, the same subject, he gets 90, he gets 80, you get 70. The next day, she gets 90, you get 80, he gets 70. Can I grade your intelligence? No, because of what? You are still getting. Yeah, it is not something I can't just say, okay, she has gotten 92 times, then she should be first. He has gotten 82 times, then he should be second. Do you understand? It's something I can see. That, okay, this guy is tall. That guy is. If robbers came to attack now, then they are of different heights, and I'm to give a statement in his station, I can always tell them that, okay, one was a little bit short, the other was averagely tall, then the last one was very tall. I can grade it because it's something I can see. But imagine the police station asking you to grade them according to their shooting skills. Okay, who was able to pull the trigger more? Can you do that? No, because I have to tell you to pull the trigger before you pull the trigger. Before I can know if you can do it. Do you understand? So that is why you hardly find a physiological type of variation under continuous. Do you understand? So that's for that. Then
you should the parents and their children, like maybe the father
yes,
and his children have the same kind of fingerprints.
you can't have the same kind of.
I don't mean the same
No.
actually. Maybe like
Yes.
and
Yes, it's not something that genetics determine. I have my fingerprints before I grew up. So if I marry and I give birth to a child with loop, it's sort of a coincidence. You understand? Or it can also be from the gene. It depends. It can be from the gene, like a kind of body appearance. If I'm fair and I give birth to a fair child, you can attribute it to my genes. So it can be part of the genes, you understand? But does not mean we both thumbprint, or I can thumbprint on my dad, or he can thumbprint on my behalf. You understand? So that's it. For fingerprints, they can't thumbprint for each other. No two. You know, if you have fingerprints, why do you think it's adopted in examination cases? At least examination, there are twins that write exams, right? But still, you can't. If you see people that want to commit fraud in the sense of writing exam in place of somebody, and that exam has to deal with thumbprinting, like JAMB. To my best knowledge, they go with that person to the center. It is the person, the owner of the details, that thumbprints. You understand? The person that wants to write the exam for that person cannot thumbprint for you. So they have their crooked way of doing it. I thumbprint and I leave the center. I can just tell you that, okay, I want to use myself, and I get out, I just go home. Then you what? You enter inside. So there's that situation is an agreement between both parties. But something is sure, and what is sure is the person standing in for you in that examination cannot thumbprint for you. It's very, very sad. Even if it is your twin brother, the person can't. So that's that. Or have you not seen cases of those of you that have twin and you are using Android phones? Can your twin open your phone if you don't register a print? So that's it. It's as simple as that. Yeah?
About the thumbprint, assuming you have a wound in that finger.
Yes, if you have a wound, technology is a robot. If you have a wound or a kind of inflammation, your phone may not recognize your print because it has damaged that part. You understand? So when fingerprint first came out, I don't know if they've improved the technology. When fingerprint first came out, that was not at its best. If your mom flog you on your finger and your print is disabled, you can't open your phone. I don't know of now. You know, as we go on, technology improves. There might be the sensitiveness might have been increased. You understand? Okay, then the sensor can still determine that yes, this is the owner of the print. You understand? So if your print is inflamed or your thumb is inflamed due to one thing or the other, it can affect your print. You understand? So that's it. So the causes, from what I said the reason why we are all different can be attributed to what? To the genotype and the environment. Now let's talk about the genotype. Genetics and environment. No, now for the environmental factors, we can have different factors can cause it. Let's just sum it up to geography or the geographical location. Then the appearance of the individual. The appearance of the individual. So every time we talk about under environment, we fall under what? Under these two. Now for the genetics, you can either have mutation under genetics. You can either have mutation or you have sexual reproduction. For mutation, you can either have the chromosomal mutation or the gene mutation. Then for sexual reproduction, you can either have random crossing over and random assessment. Please, this is not the end of variation. No. You still have some other parts to touch. Then under gene, you can have gene insertion, gene subtraction, or subtraction, or deletion. Then the last one is substitution. So this, from what I'm saying, is like this is like the major one. But let me say this has the large percentage of how you look like physically. You understand? But let's start with this environment. Now, if you have, it is very obvious the way we look like in Africa is different from the way we look, or the way human beings look like in Europe or Asia or other continents. Do you get it? And apart from the fact that our genes are not the same, the environment also affects that outward look. The way rainfall, you know, if you have gone through biology before, when we get to ecology, we discuss some parts with rainfall that we call the tropical rainforest. We have the savannas, we have the estuaries, we have the Guineas and all those places. Those places have they have different amount of rainfall and different amount of sunlight. Those things affect the way we look. Do you get it? An example is, if you notice some people right from their young age, they were light skinned. You understand? Then maybe they grew up in a state where during the sunny season, the intensity is always high in that state. Like in the north, when it is sunny in Nigeria, the intensity is always high in the northern area, the northern states. And if they are, let me say, they are prone to going out, maybe due to being a working class or due to something is taking them out of the home every single day, they'll get to a time that the rays of the sun will affect their skin and they begin to go dark. You understand? So the too much intensity of sunlight on your skin is what can affect your skin color. It can burn your skin. That's what they say, skin burn. It can burn your skin. So if I'm dark and you're fair, and we are both brothers having the same gene, you understand? People expect us to have the same complexion, but we'll be different. Why? The environment. Maybe right from when we were small, our parents were maybe underprivileged to cater for both of us simultaneously, and I was being sent to their immediate brother, who is my uncle, to live with. You understand? And the person stays in the northern part of the country. We are both fair. You understand? But after maybe 15, 16 years, when we reunite as brothers, we are now fairer than me or fairer than your brother you left at home. What has happened? It is the geography that changed, like the location changed. Then the factors that we can't change, that's the abiotic factors that we can't control. You understand? Like rainfall and so affected your other brother in the different location. So location affects how you look. Some places, where you have people that are in temperate regions that are cold, the Australia and other places, they don't look the same way we look, because we are prone to eat here. Any small thing eat, sea life they still eat. Because of the sun. The sun is intense in this part. This is tropical region, so the sun is intense here. If you look at the map, the globe, the tropical region is closer to the sun, so it is accountable for the way we see sunlight or the way we experience sunlight here. Those places are far deep, they are far away from the sun. So any little cold that we have here, it means a lot there. If you are in a cold environment here, maybe measuring 2019, this measure around 2, 3, 4, 10 in those places. And 0 is the freezing point. If you are measuring 15 already, that's an intense cold environment. You can't live. You can't live successfully. You have to have a maybe bonfire in your home, inside your house, not compound, inside your house, that keeps on eating up the environment. So environment can affect the way we look. If you have a step brother that was taken to that part of the world for maybe 10 years, if he comes back to Nigeria, he won't look the same way as you. Like a twin brother, despite what? Despite the identical or the similarity in your genes, you understand? Then the appearance of an individual, this one is another thing that can't be controlled in a way. If I was being given birth to in a rich home, or let me say my parents are rich and had 2 children, like twin, that has identical genes, then something happened along the line of birth. One child was misplaced due to some fraudulent aspect or fraudulent practices in the hospital. The child was misplaced. Like the mother of the child don't know that she even gave birth to twins. They can always They can always take away a child, maybe to sell to somebody else. We see it in some ridiculous hospitals. If by adventure the child was being sold to an average family, that means that is not as okay as my family. We are twin brothers, right? But we are really in different families. If we are both nurtured up, me, I'm always affluence. I ate milk till I'm 3. That one 2 months already eat amala. We can't be the same way if you grew up. If I'm always in AC, like my room, everywhere I am, I'm always under air condition. My dad's car, air condition. The only way I feel it is in school. But you eat school, eat class, eat church, eat everywhere. We can't look the same way if you grew up. So, but what? We have the same genes, right? So our variation in characteristic is not what? It's not being attributed to genetics because we have the same gene. But what changed? The environment. Do you get it? So these are things that you can relate to. They are not foreign things. If you see your friend, if you notice, people have friends that are maybe from GS3, she messaged you with +221, so you're already in Canada. By the time your growth won't be the same way. Even if you're under the same parents, your growth still won't be the same way because they are exposed to a different environment. So their body is being accustomed to a different weather, a different lifestyle, different from yours. So you won't look the same way. So those are what can affect cases of people with the same gene. Now let's move to genetics. Even inside the same family, some of these things can account for why you are different from your brother. And one of them is what? Mutation. Mutation is the permanent alteration of the genes. If you're writing down, excuse me. Mutation is the permanent alteration of the genes. That's when your genetic formation, your genetic code, your genetic makeup changes all of a sudden due to some things that we can't control. What happens there is what? Mutation. So it's a permanent alteration of your genetic makeup or gene. That's mutation. Sexual reproduction is not a new term. It's what? It's a copulation between a male and a female to give birth to kids, be it animals or human beings. But let's maintain human beings that we can relate to. Now, if you have studied the textbook very well, where they are describing types of reproduction, asexual and sexual, if you look at the characteristics of sexual, one of them is that the offspring don't look exactly like the parents. You understand? That is one characteristic of variation, or that is one thing you can call variation. They don't look exactly like their parents. And why? Because there has been a mix in the genes. I'm the father, you are the mother. We exchange genes, we mix genes to give birth to what? To a kid. So, random cross. Random cross is talking about, let me say, a tall father and a short mother. If they mate together, they won't give birth to, they will give birth to a tall child physically, but that tall child, his genetic composition will be what? This, a big T and a small t. In genetics, we call this what? Heterozygous tall. That means a gene for shortness is what? Is among. Now, is this child genetically the same as the father?
No.
Is it genetically the same as the mother?
No.
But it's their kid, right? It's their child, right? That is what we call variation. If this child goes ahead to marry a wife looking the same way like him, and you cross, there's a part, or probability says, let me say, it is not determined by anybody, it is determined by probability. It says that your kids, you can have one child with what? With this genetic composition. And that child will be what? Phenotypically short. But if you notice, is the grandfather short? But the grandmother is short, right? But people that gave birth to him, are they short? No, but the child is short. So genetics is supposed to understand that for the child to be short, the father and the mother both have what? A gene for shortness. So it is a random cross. You can't determine. If you have a guy and a lady that comes together to marry, and they are both having the same gene, the doctor cannot tell them that your first child, though, it is the gene, it is your own, it is this one for you, the father, and this one for you, the mother, that will come together. It is, the doctor cannot ascertain that. It is a probability something. You understand? Because the man will release the semen into the female, that's the sperm that carries different characteristics. So if it is the sperm taking this, if it is the sperm that is handling this and that having these characteristics that are coming together, or that fertilizes the egg of the mother with this, then you are having a what? A short child. But if it is the sperm that has these characteristics of tallness that fertilizes the egg, then you'll be having what? A tall child physically, having what? A gene for shortness. So random cross can affect why we look different, because the cross that happened when they gave birth to me is not the cross that happened when they gave birth to my sister. It's not the cross that happened when they gave birth to my kid brother, or as the case may be. The cross that happened when they gave birth to me, in the case of fraternal twins, there are type of twins we have. We have fraternal twins, just note that, and identical twins. Fraternal happens when two sperms ovulate the two eggs at the same time. Understand? Women have two eggs, and during ovulation, the two are open for ovulation. So fraternal twins happens when one sperm from the man fertilizes the egg of one, another sperm fertilizes the other. So at that moment, you're having two babies from. It's very rare, but it happens. Like, when I mean rare, compared to the normal one where you have one fertilizing one. But the identical, you have one fertilizing one, that's one sperm cell fertilizing one egg cell. Then during formation, the zygote divides. You understand? So that's when you'll be having identical. That means it is one gene that divided. That's when you'll be seeing identical twins that you can't even say this is Taye, this is Kende. You understand? But the fraternal, it is not the same gene, because the sperm that fertilize one is not the same that fertilize the other. So they'll say they are twins, right? But they didn't come out to look the same, because it was not the same. It was not the sperm with the same characteristics that fertilizes both eggs. So that's for random cross. Yes, your question.
can we say twins can have different fathers?
Different fathers? No. Because the thing is, in a case whereby that might it can be possible, but if you want to tailor it to be possible, even though it can be possible, if you have if a lady sleeps with a man, you understand, and he releases his sperm into her body, then the next minute she's another man. That if the sperm of the first man successfully fertilizes his own egg, our own egg, then this thing is closed. Then the next man comes to fertilize. Yeah? No, not that. Even the other egg, it can't fertilize it again. When you have fraternal twins, it is happening at the same time, because when a man ejaculates, millions of sperms are released, and they are traveling at a great speed to fertilize the female's egg. So it's a process that sometimes two fertilize the two for the woman. Sometimes, but that case, two fathers means the woman has slept with two different men. You understand? And the distance is quite, you understand? So that's it. So crossing over is another, because I'm trying to explain this thing very well so that you can understand. Crossing over is another factor under sexual reproduction. Crossing over just talks about the exchange of genetic materials. The exchange of genetic materials. You people have heard of mitosis and meiosis. Mitosis and meiosis. Meiosis, we have what? Meiosis 1 and meiosis 2. You know, when we talk about when we get here, we'll discuss properly. We have some stages. I think he discussed the stages, right? I didn't say it one day. Okay, said he mentioned IP maths or something. PMAS, okay. Prophase, metaphase, anaphase, and telophase. So for the anaphase, for the prophase, we have some sub-stages again. We have some sub-stages that we'll discuss. So under this, you know what is happening when a sperm cell and an egg cell is coming together is meiosis. Don't forget, it's meiosis. You're having what? N coming together to give two N. So it's meiosis. So, and that short process that looks like sperm breaking the egg cell, fertilizing into zygote, then into embryo. As short as it is, it has gone through what? All these stages. Do you understand? Exchange of materials. When you get to prophase, under the sub-stages, there's a stage where we call the chiasmata stage. That is where crossing over occurs, crossing over of genetic materials. An example is this. If you let us assume this is genetic material, like for the man, these are the chromatin threads. If you have heard of it before, then for the lady. Now this is the thread. The thread is housing so many genes. On this thread, there's gene for tallness, for fairness, eye color, hair color, everything is there. This gene too for the lady has hair color, eye color, and everything for the lady. Now, when they come together, in one of these stages, the two of them comes together like this. They are attached already. Do you get it? They are attached together. Now that period where they are attached, they exchange materials. So if on this part you have tallness, you get it, and it coincides with this part, and they exchange. When they exchange, they get released. You understand? At that moment, what has happened? They've exchanged a particular material. Maybe normally the woman is fair and tall. Now the woman is fair and tall. This is where the tallness gene is on her thread. But the man, when they fused, the man's shortness now exchange with her tallness. By the time she gives birth to a what? A fair but short child. Who wants the shortness? The father. Who wants the fairness? The mother. What has happened? They've exchanged materials. Now, the child is different from both the father and the mother. You can owe that to what? To crossing over. The genes are what? They crossed. So they exchanged the materials. Do you understand? So that is for crossing over. Now, random assortment. This one is like random cross, but talking about one or two or more genes. Like if you're having a father with tallness, fair complexion, blue eye color, coming together to marry a lady that is averagely tall, a brown eyed color, and kind of dark a bit. You understand? So if you're having both of them coming together, their genes are sort randomly. The gene will not say, okay, the father is tall. Did you not say the father is tall and take, okay, because I'm tall and I'm blue-eyed, then the child must be what? Tall and blue-eyed at the same time. Do you understand? If the father is tall and blue-eyed, the tallness can go and meet the brown-eyed to what? To meet together. And by the time they'll be giving birth, they'll be having what? A child with tallness and what? And a brown eye. So, but the father, what does he have? Blue eye, but he's the one that is tall, right? The mother that is averagely tall is having what? The brown eye. What happened there? Random assortment. The genes have mixed randomly. They didn't assort to give whatever one have. So that's for sexual reproduction. So sometimes these cases under sexual reproduction can bring about what we call variation. If you have a sister here or you have a brother here, and I don't know two of you before, I can't just come inside and say you are a brother or you are a sister rather. Except if I have a foreknowledge before. You understand? If I don't have a prior knowledge, I can just come into the class and say, okay, she's your sister or you are a sister. Because I can't really see the similarities until you tell me that, okay, you're from the same family. So if I'm not surprised that why are you now different, that will call what? Variation. So please, you get it? Variation. That's why we are different. And why are we different? Our genes, our parent gene didn't mix the same way. You understand? It's crossed. The assortment was not fixed. It was random. Do you understand? So that's that. So back to mutation. Please, we are sleeping, please. Mutation, we have two types of mutation. We have chromosomal mutation and gene mutation. From the name, that means they occur at different levels, right? For the gene mutation occurs at the genetic level, at the gene level. But chromosomal mutation occurs at what? At the chromosome level. Now, when you have cases of mutation for the gene,